Ever wondered how objects work in C++? Well, you're not alone. Let's delve into the world of objects in C++. In the realm of programming, objects are a fundamental concept. In C++, objects are instances of classes, encapsulating data and behavior within them. In essence, they are the digital equivalent of real-world entities, embodying the properties and actions of these entities within the confines of code. Just like a car in the real world has properties like its color, brand, and model, and actions such as starting the engine or honking the horn, a car object in C++ would hold similar properties and actions. The properties are represented as variables: brand, color, model, and the actions are expressed as functions: start engine, honk horn. But how does C++ know what properties and actions a car object should have? This is where classes come into play. Classes are the blueprints for objects in C++. They define what properties, known as member variables, and what actions, referred to as member functions, an object of a certain class should have. If we consider our car example, the class would be the car's blueprint, and a specific car, say a red Ferrari, would be an object of the car class. Creating objects in C++ involves instantiating a class, a process that allocates memory for the object and initializes its member variables. For instance, if we create an object of the car class, we might name it myCar. This myCar object now has its own set of member variables, like brand, color, model, and member functions like start engine and honk horn. Objects in C++ are a powerful tool, allowing for a structured and modular approach to programming. They enable the modeling of complex systems and the organization of code in a way that reflects the real-world entities they represent. They form the basis of object-oriented programming, a paradigm that has greatly influenced modern software development. At their core, objects in C++ are a way of translating real-world entities into code. Now that you know what objects are, you might be wondering, how do we create these objects in C++? Well, objects in C++ are created by instantiating a class. This process involves two steps: allocating memory for the object and initializing its member variables. Let's use the car class as an example. Suppose we've already defined a car class with member variables like brand, year, and price. To create an object of this class, we just need to declare a variable of the car type like this: car myCar. That's it. We've created our first object myCar, which is an instance of the car class. We've allocated memory for it, and its member variables are ready to be initialized. To do this, we simply use the dot operator, like so: myCar brand =, Toyota, myCar year =, 2020, myCar price =, $20,000. And there you have it. We've just created and initialized an object in C++. But what if we want to create another car? Well, we just repeat the process. Let's say we want to create another car. We declare it the same way: car another car, and initialize its member variables: another car brand =, Ford, another car year =, 2021, another car price =, $25,000. What's important to note here is that each object has its own set of member variables. So myCar and another car, despite being instances of the same car class, have their own unique brands, years, and prices. But what about behavior? Well, objects can also have member functions. For instance, our car class can have a displayInfo function that prints the brand, year, and price of the car. We can call this function on each object independently using the dot operator again, like this: myCar displayInfo, another car displayInfo. So, creating an object in C++ is as simple as defining a class and then creating instances of that class. Each object is a unique instance with its own data and behavior. And it's this ability to encapsulate data and behavior that makes objects such a powerful tool in C++ programming. Objects are great, but how do we initialize them? This is where constructors come into play. Constructors are the unsung heroes of object-oriented programming, especially in C++. They are special member functions that have the same name as the class and are automatically called when an object is instantiated. Constructors set the stage for our objects, getting them ready for action by initializing their member variables. To understand this, let's consider a simple example: a rectangle class. This class might have two member variables, length and width. Now, when we create a rectangle object, we need to give it a specific length and width. But how does the object know what values to assign to these variables? This is where the constructor steps in. We can create a constructor for the rectangle class that takes two parameters, one for length and one for width. This constructor will be automatically called when a new rectangle object is created. The values provided as arguments when the object is instantiated will be used by the constructor to initialize the length and width of the rectangle. Here's what the code might look like. We define a class rectangle. Inside, we declare two private member variables, length and width. Then we define the constructor. It's a public function with the same name as the class, rectangle, and it takes two parameters. Inside the constructor, we assign the provided values to the length and width variables. When we create a new rectangle object, we provide two arguments. These arguments are passed to the constructor, which uses them to initialize the length and width of the rectangle. So when we say, rectangle my rectangle equals sign rectangle 5, 3, we're creating a new rectangle object called myRectangle. The constructor is called with the arguments 5 and 3. It assigns these values to the length and width of myRectangle. Constructors are the magic behind the scenes that set up our objects when they are created. They ensure that our objects are ready to perform their tasks from the moment they come into existence, making our code more efficient and organized. Objects can do more than just hold data. They can also interact with each other. Let's see how. In the world of C++, objects interact with each other through member functions. Think of member functions as the actions that an object can perform. These functions can access and modify the member variables of the object on which they are called. This means that an object can change its own state and, by extension, the state of other objects. Consider the example of a bank account class. This class might have member functions for depositing, withdrawing, and displaying the balance. Let's take a closer look. Imagine you create an object named myAccount from the bank account class. You could use the deposit member function to increase the balance of myAccount. This function would access the balance member variable and add the deposit amount to it. In a similar fashion, you could use the withdraw member function to decrease the balance of myAccount. This function would access the balance member variable and subtract the withdrawal amount from it. Lastly, you could use the display balance member function to print the current balance of myAccount. This function would access the balance member variable and output its value. In this way, the member functions deposit, withdraw, and display balance allow the myAccount object to interact with its own member variable balance. But the story doesn't end there. Suppose you create another object named yourAccount from the bank account class. myAccount and yourAccount could interact with each other. For instance, you could use the withdraw function on myAccount and the deposit function on yourAccount to simulate a money transfer between the two accounts. In this way, member functions not only allow an object to interact with its own member variables, but also facilitate interactions between different objects. This makes member functions a powerful tool in C++. They enable objects to model complex behaviors and relationships, bringing us closer to simulating the intricacies of the real world in our programs. Member functions allow objects to interact with each other and perform actions on their data. We've learned a lot about objects in C++. Let's summarize the key points. Objects in C++, as we've seen, are instances of classes. They encapsulate or package together data and behavior, representing real-world entities in a way that makes sense within the context of our programs. They're like individual actors on the stage of our code, each with their own unique characteristics and abilities. Creating these objects involves a process called instantiation. This is when we take the blueprint provided by a class and bring it to life, so to speak, in the form of an object. Just as an architect's blueprint becomes a house, a class becomes an object. We allocate memory for the object and initialize its member variables, giving it the attributes it needs to function within our program. And speaking of initialization, constructors play a crucial role here. These special member functions have the same name as the class and are automatically called when an object is instantiated. They ensure our objects are born ready with all their member variables set and ready for action. But objects aren't just passive data containers. They interact with each other through member functions, accessing and modifying each other's member variables. This is where the real magic happens, where the objects in our programs communicate, collaborate, and sometimes clash, creating the dynamic, interactive experiences we know and love in our software. So in essence, objects in C++ are a way of structuring our code. They allow us to model complex systems in a way that's modular and manageable. They're like little code modules, each doing their own thing, but also working together to create the overall functionality of our program. Objects in C++ provide a structured and modular approach to programming, making it easier to model complex systems and organize code. Keep practicing, and you'll master objects in C++ in no time.